All right, I think we'll get started. So, hi everyone, thanks for joining us this evening. A couple of housekeeping items to begin. Can everyone please make sure that your microphone is muted and your video is switched off? To begin, I will give an introduction to the Institution of Structural Engineers and then hand over to Chris Buntine, who will give an introduction to Engineers Declare before we jump into the presentation. There will be an opportunity for about 10 minutes of questions at the end of both the presentations. Can you please type your questions in the chat box, and when the presentation is finished, our speakers will answer as many as possible. So to begin, introduction to the Institution of Structural Engineers, or otherwise known as IStructE. We are the world's largest membership organisation dedicated to the art and science of structural engineering. We uphold standards, share knowledge, which is like what we're doing today, and promote structural engineering and provide a voice for the profession. The current activities for IStructE Queensland Group. So this is our first webinar for 2021. The next webinar we're aiming to have is about construction engineering, and that will be late April. The second half of the year, we will look to hold some more face-to-face events, all going well. Another thing we've got coming up is the Chartered Membership Examination Prep course, and that's 6 sessions between May and July. Get in touch with istructe.arg.queensland@gmail.com if you're interested. The course will be held as a mix of online and face-to-face sessions. If you're thinking about sitting the exam this year in September, or even just thinking about sitting the exam in the future, this will definitely help with your present preparation. There's also a lot of online resources on the IStructE website on all things structural engineering, but there's also a whole section on the website related to the climate emergency, which has resources that are useful to everyone, not just structural engineers. Last thing I want to touch on before handing over to Chris is that the new CrossOz has just relaunched with the new website. Cross previously stood for Confidential Reporting on Structural Safety, and as part of our relaunch, we have a new name, Collaborative Reporting for Safer Structures. The new name reflects the integrated way in which professionals collaborate for a common purpose. CrossOz improves structural safety by sharing lessons learned. It is a confidential reporting scheme to capture information about structural safety issues and share these in a public manner. Their de-identified information published on Cross, names of individuals, companies, projects and organisations are never made public. The panel then provides expert commentary to help engineers learn from experience of others. And CrossOz aims to help improve the public safety. I'll now hand over to Chris, who's going to give a quick background and a bit of information about Australian Engineers Declare. So I'll hand over to Chris.
Great, thanks, Susanna. One of the reasons that events like this are occurring is because we are in a climate emergency, and across the engineering profession, we're realising we really need to take action. And so I'm going to talk briefly about the Australian Engineers Declare network, which has really come from, or can some of it's it's coming into being from what's happened in the UK. So like some of the other information we'll hear today, we can thank those engineering and architectural organisations in the UK for their good work in really leading in this space. But Australians are stepping up as well across the engineering profession. Recently, The Guardian ran an article talking about how the oil industry has known for 50 years that the burning of oil caused health problems. They've kept that information secret, and then when it was more public, they denied it, and then they delayed it. And so the question is, how will future generations look back on the engineering profession? The clock is ticking. We've known actually about the impacts of the built environment and the use of structural engineering materials on climate change for quite a while now. So we don't want to get to that 50-year point. there's a real question of how do we respond and how quickly, and how do we make sure we don't procrastinate like other organisations have in the past. So just briefly, Australian Engineers Declare has about 1,900 individuals that have signed up, as well as 200 students and supporters. It's set up to allow you to sign on as an individual or an organisation, so it's a bit unique in that respect. Most other engineering declare networks or architects declare are just for organisations. We wanted to support individuals within those organisations as well. So it's growing, expanding, and invite you all to become part of it. The vision is pretty simple. That the Australian engineering profession leads a rapid and just transition towards healthy, thriving communities and ecosystems. So recognising that there's this an externality to what we do, and we need to take responsibility for that. And that's a huge opportunity and a really inspiring opportunity to lead. Lots of things happening around Australia. There's a newsletter we put out which gives you access to all kinds of stories. We want to share those stories of success, recognise that there's a lot happening. There's region hubs that are launching. There's events like this that are being publicised. So it's building, and we're all working together to see what it means to respond to the climate emergency. And it's really about accelerating that change, providing a platform, not another organisation. This is a network. We're trying to amplify what existing organisations and individuals and organisations are doing, and being very inclusive in the process. Really focusing on mobilising, getting that momentum going, connecting with each other, finding resources. That transformation part, we really need to shift engineering practice and normalise some of the things you'll hear about this evening, and just make it easy and accessible. And to amplify that voice of the profession. So we're at the table, we're helping influence policy with government and drive change. And the way we're doing that is through a coordination group, which I'm part of, launching region hubs. So there's one in Brisbane, there's in Melbourne, we're launching them in other places. So they're meeting regularly, drawing people together, but also focusing on key areas of change where we need to put in place initiatives, so what we're calling thematic hubs, to focus on, bottlenecks that are standing in the way of accelerating change in the way we do things. And tonight's session is a perfect example of how the engineering profession is lining up with the declaration, really, which includes 12 principles, but here's some of them. It's about raising that awareness. How do we evaluate new projects, accelerate change, take a whole of life approach, collaborate across the professions, shifting to circular economy principles, particularly as we look at materials, sharing those stories of success, and as well as knowledge and research. So this is exactly the kind of event and initiative that we'd love to see more of. And just lastly, quick inspirational message. Rick Hoyt was a quadriplegic with cerebral palsy, and he convinced his father to push him, and they would do marathons and endurance events together. So initially doctors said Rick couldn't do much in his life, but together with his father, they became amazing examples. They were in the US of inspirational efforts and overcoming challenges. So they completed over 1,100 endurance events and over 71 marathons, and completed the Boston Marathon over 32 times. And there's a plaque now next to the Boston Marathon that reads, "Yes, you can." And I think of what we're trying to do in the engineering profession in a similar way, in that we're trying to, in it for the long haul. This is not going to be easy. We're running a marathon. There's this decade and the following decade. So let's keep this message in mind. Yes, you can. That's certainly what we can do in the engineering profession. And that's it from me. Oh, and just how you can get in contact. There's a website, email, etc.
Thanks, Chris. All right. What you guys are all probably very excited to hear. So I'll introduce our speakers now. So firstly, we're going to have Will Arnold speak. So Will is the head of climate action at the IStructE. He leads the institution's response to the climate emergency, bringing this action into all aspects of our work, including the publication of best practice emergency guidance. Prior to his current role, Will was a practicing structural engineer at IREP for over 10 years. He sits on the Structural Awards judging panel and is a member of the Engineering Advisory Group for the Structural Engineer. After Will does his presentation, we're going to also have Lachlan Ramsey and Richard Feigin, I think is how you say it last name. So Lachlan as a senior structural engineer with AECOM's Building and Places team in Melbourne. Lachlan has worked on a range of projects across the health, education, commercial and residential sectors. Over the last 18 months, he has been a part of an internal initiative to develop AECOM Australia's capability in the space of sustainable engineering design. Lachlan is passionate about promoting the role that all engineers and consultants can play in reducing life cycle emissions in the building and construction industry. Richard is a chartered structural engineer with AECOM's Building and Places team in Melbourne. He has 11 years experience across a wide variety of sectors, including residential, commercial, industrial, sports, mining and aviation, and has worked both in the UK and Australia. Utilising a second degree in computer science, Richard specialises in parametric engineering and computational design. He brings these skills to AECOM's embodied carbon initiative, as well as his focus on sustainable living and minimising our carbon footprint. Now I'm going to hand across to Will and he will give his presentation.
All right, okay, thank you, Susanna, and thank you, Chris, as well. I think that was it's quite good to hear people from Engineers Declare talk about it, because I think that the relationship that the IStructE holds with Engineers Declare in all its different forms around the world has actually been pretty good ever since it's set up. It's almost like, you know, two slightly sort of separated brothers. I don't know, we've got a lot of overlap, but we're not quite the same thing, if that makes sense. But we're certainly trying to move towards the same end goal. So good to hear that introduction. And if anyone's listening and you haven't signed up to Engineers Declare, please do. There's a lot of power that comes out of just having all of us sort of signing something to say that we're all striving towards the same goal. It's things like that that are making governments around the world listen, and so on and so forth. Yeah, so I'm head of climate action at the Institution of Structural Engineers. I'm based in the UK, but we are a global institution, and so I find myself getting up at all kind of weird times of the day to do things like this. Thankfully, it's only 8:45 in the morning for this one, so not too bad. I'm going to talk for probably 15 minutes or so. I'm going to do a sort of big picture type thing, recap on what the hell's happening to the world, why it matters to us, what our responsibility is. And then Vicky and Lucky are going to give you some more, I guess, sort of more specific project-based type examples and give you some inspiration for what you could do in your own work. So, all right, we'll start with a sort of recap of what's happening to the world before we move on to some things to do about it. So this is going to get pretty dark and nasty before we see the lights at the end of the tunnel. So this is a report that was written in 2018. And this is a report that talks about what we think is likely to happen to this planet if global warming exceeds 1.5 degrees Celsius, or if it's capped to 1.5 degrees Celsius. And the report highlights that if we are going to keep global warming within 1.5, we need rapid, far-reaching and unprecedented change. Now, those are big words, but they're words that you've probably heard quite a lot over the last year. But this is something else. This is much bigger and scarier even than COVID, and you've even got politicians around the world starting to sort of wake up and agree with this. So this is a big thing that we need to start dealing with. And this graph is about to show you why, hopefully. So this is humanity's carbon emissions from the last 60 years. This line is not cumulative. This is emissions per year, and it's going up horrendously fast. So in 1960, you'll see that humanity was responsible for the release of about 10 billion tons of carbon into the atmosphere. That's carbon dioxide only, so there's some other greenhouse gases as well. You need to add 10-20% to the line of the graph. But 10 billion tons of carbon that year. By 1990, we were up to 20 billion tons of carbon, and we're now up at about the 40 billion tons of carbon mark. This is going up and up and up. you'll note that there are some pretty important climate summits marked on this line, but they do very little to change the general direction of it. And actually, if you add up the total emissions that have happened since Rio 1992, that adds up to more than the total emissions prior to Rio 1992. So in other words, we've emitted more carbon whilst fully informed of the consequences than we ever managed to do in ignorance of them, which is not very good. We also know what needs to happen next. So we need to more or less halve our emissions by 2030, and then we need to be down at zero by 2050. So the left-hand side of this graph is increasing faster than it's ever increased in the history of the planet, but the right-hand side needs to go down faster still, almost twice as quickly. So the left-hand side of the graph is like a sports car accelerating up the start line. The right-hand side is pretty much us slamming on the brakes before we crash into a brick wall and die. It's a pretty brutal reality type thing. But we've only got about 8 years and 9 months left until we need to halve those emissions. So the clock really is ticking, and these are not long timeframes that we talk about. I don't imagine many of you are planning on retiring in the next 8 years, 9 months. So you might as well start getting excited about things like carbon calculations. In fact, before long, this is going to become a legal obligation. So whether you're interested in it or not will kind of be irrelevant. So the countries marked in green on this map have net zero legislation either in place or currently in draft form being debated. Orange countries have official government policy to the same sort of effect, and the red countries are in formalized discussions around taking those first steps. You should note that for Australia, this is shown on a state level. So at the moment, I don't think there's any sort of national policy to this effect. But the summary of this map, and just in general, this is only going to go in one direction from here. This map was pretty grey and colourless a couple of years ago, and even a year ago there wasn't really much on this. This map changes, month on month. So it's pretty inevitable that we're going to be working within net zero carbon legislated countries over the next few years. And the next step that we're going to see after that, of course, is that in these green countries, you've got departments at central government, local government, city hall sort of levels, all starting to get their heads around whole life carbon, embodied carbon, and what they need to do with this if they're actually going to meet those 2050 targets. So this is certainly something we're seeing all over the UK at the moment. Is pretty much every city in the country is trying to work out how they can start to get on track for 2050 and what the interim steps are, which means that carbon targets, planning limits, things like that are all coming. We know they're coming because there are draft documents out for guidance that include carbon targets in the back of them. And whilst I'm speaking from the point of view of the UK there, this is something that we speak to people in other parts of the world and they say, we're on a similar trajectory. It's a case of when rather than if. So this is very much, on the horizon if it's not already here. So, okay, so that's what the law tells us needs to happen, but I think it's worth taking a minute always to remind ourselves of why, because the why is really important here. Let's look at the difference between 1.5 degrees temperature rise and 2 degrees temperature rise, because after all, that sounds pretty small, right? So at 1.5 degrees, flood risk around the world doubles. But at 2 degrees, more or less triples, okay? That's the difference that 0.5 degree makes. In southern Australia, in New Zealand, at 1.5 degrees, the frequency of warmer days, which is hotter than average days, more or less doubles. So imagine those hottest days where you don't really want to go outside. You've got almost twice as many of them. But at 2 degrees, it's more than triple. Likewise, around the world, at 1.5, we have about 700 million people exposed to severe heat waves every 20 years. But at 2 degrees, that goes up to 2 billion. So that's more than Australasia, North America, South America, and Europe put together. Huge amount of people. And that's every 20 years. So that's 3 or 4 times in your lifetime, the sort of heat wave that kills people. So 1.5 is pretty important. And if we can't meet this curve, we don't manage to meet this curve, things are going to get pretty uncomfortable by the end of this century. Now, we talk about the end of this century because that's the time frame used in most of these reports. They mostly run up to the year 2100. And I think that a lot of people forget how close that really is. So as a reminder and as a way of tugging on your heartstrings on a Monday evening, this is my nephew, Baby Bobby. So Baby Bobby was born in 2019. So that means that when we talk about things in the year 2100, we're talking about stuff that's going to happen when Bobby is 80 years old. So it's old, it's not that old, is it? He'll probably be retired. You might even be a grandfather. Now, I'm sure that all of you can think of somebody like Bobby. I just want you to picture that person for a second, and I want you to imagine them on their 80th birthday, maybe blowing out candles, having a barbecue, whatever, surrounded by their family and by their friends. And I want you to think about the sort of world that we might have left to those people. Every decision that you make on every project you work on matters. And from now on, you're making those decisions informed of the consequences, not ignorant of them. Those decisions that you make are going to impact the lives of people you know and people that you love. So it really is time that we change what we do. Right, the good news in this, because I did promise that it was going to get dark before we came back out the other side, and this is the other side there. So structural engineers, we actually can make quite a big difference in all this. Some of you might have seen these numbers before. Globally, buildings and construction contributes to nearly 40% of energy-related carbon emissions. And then the next biggest piece on this chart is industry and infrastructure. So as structural engineers, we sort of sit about here, and we make up about 10% of the total. So when we talked about 40 billion tons of carbon earlier, 4 billion of that is us. That's our chunk of the pie, and that's what we have to play with and what we have to reduce. 10%, surprisingly big actually. And then there's another 10% I want you to remember, because you shouldn't forget this one. And it's to do with this graph. So this scary graph that's dramatic and unprecedented, like a car slamming on the brakes, that line on the right-hand side, that's actually just 10% per year, which doesn't sound so hard, does it? So if you challenge yourself to do 10% better this year than you did last year, that sounds pretty achievable. And then we'll just repeat and repeat. And I think that the Dick and Rick Hoyt example's a pretty good one of this being a marathon. But in a way, it's also a sprint, right? You know, we've got to start this now. The longer we wait, the higher that percentage is going to get. So 10% per year, what does that mean? Well, I think quick bit of Googling tells me there's about 20,000 civil and structural engineers in Australia. So if every one of those does 10% better this year than last year, that's about 4.5 million tons of carbon. So that's pretty significant, right? That's the equivalent of turning the power off in Brisbane for the entire year, right? Lights, electricity, aircon, everything off for a year. So, you know, this is a big piece of the pie, our 10%. This is the sort of significant change. And if you turn the power off as a way of saving the world, people might sit up and notice. But this is a collective impact, and we shouldn't forget that. So any one of us is not going to manage to do this, but we need to add up our contributions. And even if you focus all your work on small projects, you do arty things, you do residential stuff, this all still counts and this all still adds up. I mean, the COVID thing is a pretty sort of representative example of what happens when you need everyone to get behind this, but we really do. So regardless of what line of work you're in, you are counting towards this kind of saving. Right, okay, last bit for me before I hand over. So what can we do about it? We've recapped why this is scary. We've looked at how significant our contribution is, but it's obviously we need the last piece of the puzzle. How are we going to start reducing things? So some more good news to you. This website is full of free stuff, right? About 99% of it's free to our members, and over half is free to non-members as well. So even if you're not a member of the IStructE, do go and have a look. There's papers on carbon, on lean design, on understanding your responsibility. We've got viewpoints on influencing clients, all this kind of stuff. All of the content on this website is categorized under one of these 6 categories that we use because, I don't know, we sort of think it's useful to try and break this down into some steps. This whole sort of sustainability thing is quite big and scary, and you don't really know where to start a lot of the time. So we've got these 6 categories. 1 and 6, which is get informed and get involved, they kind of top and tail everything else, right? So it's worth understanding what's happening to the world. It's worth being able to communicate that to other people. So when they ask you about, well, what is this carbon stuff you keep talking about, you can sort of recount what's happening to carbon emissions around the world, so on and so forth. And then get involved in a way is, you know, the most important one on here, because like I say, this isn't about any one person's contribution. We need everyone to understand this and everyone to get behind this. And then 2, 3, 4, 5 in the middle of all of this. This is about your sort of, you know, technical things you can start to change on your projects. Counting carbon, reducing your usage of material, designing structures that can be reused, recycled, circular economy ready, that kind of stuff. And of course, trying to convince others to do the same thing and pursue the same thing. So if you go onto this website afterwards, you'll see that it's full of these articles listed like this. This is just 3 examples that I grabbed earlier, but it's all this kind of stuff. And these are 2-3 page articles. They're written in plain English. You can pass them on to architects, to clients, to your mum, whoever you want, really. The 10% thing that I talked about in terms of needing to do 10% better this year than last year, it's worth trying to understand what that means in terms of your work and how you might achieve that. Some of you might follow me on LinkedIn. I don't know. If you do, you'll notice I had a bit of a dig at Bill Gates last week because he's released this new book, which is very good. It's very interesting, and it gives you quite a nice overview of what's happening around the world. But it's all about technical innovation. It's all about new materials. It's all about the future of concrete and steel and all this kind of stuff. But frankly, that's not going to help you save 10% in 2021. Right? All of that stuff is needed, and we're going to need that to come around pretty soon if we're going to be able to keep doing 10% per year. But for this year, simply we need to use 10% less material. So actually, you don't even have to start, going out and speccing different things or speaking to different material manufacturers just yet if you don't want to. You just simply have to work that bit hard on the design to get your usage of concrete and steel down by 10%. So these triangles that you can see on the screen, this is about sort of hierarchy of impact. This is, do the stuff at the top of this first, and then work your way through it. Start questioning the brief at the top right-hand corner. Then if you are going to keep building, how much building do you need? Can we repurpose something we've already got? Can we talk about flexible usage of floor areas, stuff like that? Working your way down the right-hand triangle as you go through design. And then once you stick your design out the door for construction, only then going back to the bigger triangle on the left and talking about your specification and trying to get those last savings through your low carbon materials and stuff like that. And of course, right at the tip of this is offsetting, because it's not going to save anyone, but of course, if your client's able to put some extra money into reforestation or cookers for countries who need to increase cooking efficiency, stuff like that, that can be a good thing to do as well. But you got to go through this in the right order, and you can't really skip back up to the top of the triangle very easily once you've passed a certain point. So you kind of only get one shot at most of this stuff. Also bear in mind, of course, this is part of this bigger, knotty, complicated picture. I touched on this before. This is why we came up with 6 topics for all our own guidance, but those topics don't cover most of the things on this screen. So we've got biodiversity, education, equality. All of these things are completely interlinked. If you look at things like the UN SDGs, it helps you understand how much overlap there really is in all of this. But whilst you can't forget the bigger picture, you must also remember that the embodied carbon and the whole life carbon of a building, that's where your biggest role is amongst all of this as a structural engineer. In your day-to-day life, you might be able to save 10, 15 tons of carbon a year, but in your professional life, you can save 1,000 tons of carbon a year if you're trying. So there's this massive difference between the two. And that's why it's worth keeping that focus right at the center of your mind. This is why, in amongst all those other bits of guidance and stuff that I've mentioned, the institution's put a big effort into carbon-based content. So last summer, we released this guide that's on the left, how to calculate embodied carbon, which is applicable anywhere in the world. It's got UK carbon figures in it, but it also has global averages. And there's no reason why you can't use it with Australian carbon figures if that's what you've got hold of, and if you're doing projects in Australia. We also last month released a carbon tool, which is basically just an Excel spreadsheet version of the same thing. But both of these things it's worth remembering, they're not about calculating carbon, they're about reducing it. So this is about helping you identify where the carbon is so that you can then make good decisions with your materials so you can reduce it. I couldn't talk to you this evening without doing a 3-minute intro to the tool. I'll put up a web link at the end of this so you can go and download it after we're all done talking. But I should just show you sort of what's in it, because like I say, you can use it anywhere in the world. It is worth having a go at if you haven't done already. So this is what it looks like. It's just, like I say, it's an Excel spreadsheet. It's got some tables for putting some material quantities in, and then it gives you some data out the other end. How much carbon's in this part, how much carbon's in this part. For anyone who's listening who hasn't tried to get their head around this stuff yet, because we're all at different stages on this. This is kind of how you define the life of a building in carbon terms, if you like. So you've got these modules you see listed up here with the letters and the numbers that run from A all the way to C, which is the end of life of your building, and then you've got this big blob on the right, which is module D, which is later down the line. So A1 to 3 is about turning raw materials into a product, whether that's a steel beam or a timber I-joist, whatever it is, but turning it into a product in a factory. A4 and 5 then is then turning that into a building or a structure. So A4 is transporting it to site and A5 is building with it. The B modules, which is the green stuff, that's all about the lifetime of your building. So whilst in here it's relatively small width, in sort of chronologically, that's probably about 60 years long or something. There's not much in here in structural terms, unless you're going to start repairing stuff and replacing stuff. In our tool, we actually don't pick this up just yet. We're going to do that in a future version of the tool. But like I say, it's pretty small. And then the red stuff, C1 to 4, that's end of life, that's demolishing, processing the waste, so on and so forth. When we talk about carbon then, and I've got to do this because I'm about to show you some outputs from it and they wouldn't make sense if you didn't know this. We talk about whole life carbon. That's from raw material right up to demolishing and getting rid of the building or the asset at the end of its life. And we talk about upfront carbon. And upfront carbon, which is the emissions today, i.e. upfront before the building exists, that's the really crucial bit in my mind, because whole life carbon is important, but of course we were looking at a graph a minute ago that's got a downhill slope that's only 28 years and 9 months long. So if your building is going to last for longer than 28 years and 9 months, then we should be operating in a zero carbon world by then. So it's the upfront emissions, the stuff you're pumping out into the atmosphere today, that's what's really important in all of this. And then you should always think about things like module D as well, but just bear in mind that how this is worded is quite important. So potential future benefits, although this is your recycling and your possible circular economy benefits, that kind of stuff, but it's all a bit sort of guesswork in the future. So we've got this tool, it's got these different tabs at the bottom. The orange tabs are some basic info, project area, costs, stuff like that. The blue tabs allow you to enter up to 6 different designs that you come up with. You've got comparison tab for comparing stuff, and then you've got some grey tabs for some material data. You can name your scheme up at the top. You go through this bit of the chart and you just work from left to right. You put in your concrete, it's in situ concrete, it's got this specification, and then you put a volume or a mass in on the right hand side, and that's pretty much it. So it then calculates your carbon at these different life cycle modules for you, and it spits out a total down here, which you can see it gives you A1 to 5, which is your upfront, and then it gives you A to C, which is your whole life. And it also divides this on the right hand side, it divides it by your GIA, so your gross internal floor area. That's useful because that gives you an indication of the sort of intensity of carbon in amongst all of this. So if your project is twice the size, you should be using twice as much carbon, not 3 times as much. And then it gives you these outputs at the bottom, which are all sort of comparison things. There's a pie chart on the left. So in this case, we can see that most of the carbon's actually in the substructure or the piling. So you might start thinking about getting more ground investigation work done to try and decrease the size of those. That lets you have targeted conversations with your architects rather than just trying to push to get everything as low as you can. Stuff in the middle compares it in terms of flights and meets and dairy and stuff like that. And then this thing on the right is a sort of rating sticker that we've come up with. That takes your kilos of carbon per square meter and puts it on a sticker just so that your client starts asking for it to be green instead of red. There's some comparison pages where you can view one against the other. You can go and have a look at those in more depth. And then last but not least, like I say, the carbon figures that are in here to start with, they are global averages. If you've got Australian data or you've got sort of local average data, you can just add them into this chart yourself, and then it'll let you import them into the main spreadsheet. So if you know that you're going to be using a certain type of steel on your project, you can put in a carbon factor for that steel just here, and that drags it across. Right, that's it from me. Bit of a whirlwind. Hopefully I haven't overrun too much. Do have a look at the tool if you get the chance, and do get in touch if you've got questions or thoughts on any of that, of course. Right, Ricky, Lucky, OT, I don't know which one of you is going to share a screen, but Go for it.
Thanks, Will. Go and just get the technology working here. So can we all see that on the screen now?
Yeah, that's good.
Thanks. Wow, that's actually, I was expecting a pretty polished presentation, Will, but that was very compelling stuff. I was actually a bit blown away by it, to be honest. Ricky and I are both senior structural engineers in the AECOM buildings and places team, and we're based out of Melbourne. And our journey with embodying carbon probably started about 18 months ago when one of our facades directors was mulling over a question of whether it was better to go from double glazing to triple glazing on a building we were working on because of the additional embodied carbon that it put into the building versus the payback on the actual operational energy that it was using. And it sort of started us down a path of saying, well, why are we only looking at the facade? Why are we not looking at the structure? Because there's so much carbon tied up in it. And from there, it's really snowballed, and we just keep finding more and more things that we can do in this space and more questions that we want to have answered, I think. So over the next sort of 15, 20 minutes, Ricky and I are going to run through a few things to try and, I think we've heard some really good stuff about where the rest of the world's at and what's going on elsewhere from Will. And we're going to try and sort of Australianize that content and talk a bit about what's happening here. So I'll talk a little bit about why engineers should be interested and client engagement. We did a case study last year, which was comparing a CLT timber scheme against a concrete scheme. So I'll run through that a little bit, and then Ricky's going to run through resources that are available to structural engineers in Australia and environmental product declarations. Talk about Green Star a bit, which I think is particularly relevant for us. And also then he's going to finish up talking about government targets and the different state-based and federal-based targets that really put it in context to where Australia currently is at the moment and where we're headed. So personally, I've sort of felt a little bit like sustainability is a little bit out of my grasp in terms of having an effect on it. The traditional approach to environmentally sustainable design, or ESD, it's typically in Australia been about replacing materials, and often that, you know, say it's a 40 MPa standard mix and then it gets replaced with a low carbon mix. Often that decision is so far down the line and so far separated from the structural engineer that we have very little ability to be able to affect that. I think the other point to note on is that the operational emissions, which is shown in orange on this graph here, our clients invest quite a bit of money in trying to reduce those operational emissions for both cost and carbon reasons. And they'll invest in better facades and HVAC systems and carbon offsetting and all kinds of things. But as we move towards net zero in 2050, the effective carbon in this operational phase is going to become lesser and lesser as we rely on renewables more. And I think that's going to put even more focus on these pink sections of the graph where the embodied carbon lays and really make it more in the court of the structural engineers. And the good news is that we can affect this. And the really important thing is that we really should be at the forefront of affecting this and talking to people about it. So in regards to when you should speak to your client, the answer is day one, like talk to them straight away. I think it's when you're talking about what materials you're going to build your building out of, and the cost and constructability questions are being answered. I mean, that's the time that you should be having that discussion. This graph on the screen is sort of showing that the further you go through the life cycle of the project design, the less opportunity you have to actually affect the overall carbon. And the later you leave it, the more it ends up just becoming a replace this material kind of thing, rather than actually considering the optimization that can occur. And this doesn't necessarily mean, oh, you've got to go for a timber structure. This can be, optimizing the amount of concrete to reinforcing that you're using to actually overall reduce that carbon. And on a note of our clients, so definitely our more environmentally conscious clients are starting to ask about this stuff. We've certainly been asked about it from Lend-Lease, our government clients, Development Victoria, and a lot of architects as well. I'm sort of finding, just talking to my friends who are architects, that in all parts of the market, people are really interested with embodied carbon and where this is going. So I'm just going to touch on our case study that we worked on last year. This is about $100 million office building, which was built in a regional centre just outside of Melbourne. And it was quite unique because we actually produced 2 sets of tender documents where we actually did a conventional post-tension floor plate scheme, and then one where the floor plates were CLT timber with glue laminated beams. So part of that study too, we also looked at the transport emissions and did a bit of a sensitivity study to try and understand how they affect. And Will went through it in his presentation. The Eurocode defines A1 to A3 as from when you mine those materials out of the ground through to when you've got your concrete in your truck ready to go to site. And then that A4 category is taking it from your site to, from the factory to your site. So for this project, we looked at a few different options of structural steel sourced in Australia or sourced overseas in China. Structural steel is a small component of this job. So, and then timber sourced in Australia and timber sourced internationally in Italy. The reason we went with Italy is because this building did end up being built out of CLT, and it was sourced from Exlam Dolomites in Italy. So it's actually quite relevant to this project. And you can see there that it doesn't make up a huge component of the overall embodied emissions, but if you actually look at that 250 tonnes difference between the sourced in Australia and the sourced in Italy, that's equates to about half a year.
I think we've lost Lockie. He normally comes back after a few seconds of pausing.
Yeah, it's quite a cliffhanger he left as well.
If he doesn't come back soon, I might jump forward to my presentation. Back,
Yeah,
Lockie?
I think he's back.
Am I back?
Yep.
Talking to myself, was I? Where did we get to? Transport. I'll just try and share screen this. So we're right, we're back on the transport emissions there.
Yep, we're back, thanks.
Thank you. It's nothing, if there's always a bit of technology issues. I guess what I was touching on was just saying that 250 tonnes is a significant amount of carbon. And I think it actually ties in well with what Will was saying, is you could do all the things you want at home, but you could actually just, if they could get their procurement right in this project and we could have sourced that timber from Australia, some of those really easy wins in reducing your carbon just right there off the bat. And this final slide is about the 2 schemes. So the concrete and the timber scheme look fairly similar off the bat. So that's the 2 on the left-hand side here. And I guess like our initial assumption was that the timber was just going to be miles better than the concrete, but there's actually a reasonable amount of embodied carbon tied up in engineered timber products. There's a lot of cutting down in the maintaining the trees, cutting them down, milling, sawing, transporting, and then in engineered timber products, you've got a gluing and lamination process as well. But it's also important to note that in that timber scheme, it's also including the concrete retention and the substructure. So there's still a lot of concrete included in that. But I suppose the big thing about timber and the reason why people are going for the timber as an option to reduce carbon is that is a story about biogenic carbon and the sequestration of the carbon as the tree is growing and it sucks in the carbon. The theory for the period that the building is standing there, that's carbon that is not in the atmosphere. and new trees get planted in its place in the forestry. So when you start including that, so for the right-hand side of the graph there, you start including that biogenic carbon element, it probably equates to about a 30% reduction on this project, which is about 5 years of operating emissions. So it's a really significant saving. So certainly it's like a pretty interesting process. So I'm going to throw over to Ricky now and let him tell you a little bit about some of the resources available to structural engineers in Australia.
Thanks, Lachie. So the first thing I'm going to talk about is the resources we have available in Australia for calculating embodied carbon. So I guess the main aim that we're trying to achieve is to be able to accurately calculate the embodied carbon in the structures that we're designing. Sounds simple, but we're typically used to having a suite of tools at our disposal, formulas, software, examples of previous buildings. When it comes to embodied carbon, there are a growing number of tools on the market. That Will talked about the IStructE tool, and in Australia, there's more and more things coming online. The things are more complicated, less complicated. Some are free, some are licensed. So the calculation we're trying to do is pretty simple. Just multiply the quantity of materials that you've got by a coefficient, and you get the tons of CO2 released, and then you can compare your different schemes. We all know how to calculate quantities, and basically then the difficulty is having a coefficient that you can rely on. So the list on this slide is basically in terms, in order, I guess, of complexity. As you go down the list, what stage of a project you'd be at, and use sort of more complex tools. So the EPIC database is one that we've been using. It comes out of Melbourne University. It's government funded. It's quite a comprehensive database specifically for construction materials. It's aggregated for Australia-wide, so you can just pick it up and use it anywhere in Australia, and you've got a pretty good starting point. It doesn't allow for nuances related to where you are, who the manufacturer of the material is, that kind of thing. But when you're talking about comparisons of overall schemes, it's a pretty good starting point. EPIC will only calculate A1 to A3 emissions, so that's what we were talking about, cradle to gate. And the second point there, the Infrastructure Sustainability Materials Calculator from the Sustainability Council, that will, we found that useful to get an idea of A4 emissions, which is basically just a transport. You take a transport method, be it ship or articulated truck or whatever it is, and a weight of material, and you can calculate your emissions from gate to site. So that'll get you to site. There are licensed life cycle analysis software which will calculate your emissions. That's generally the realm of ESD consultants. It's more for a whole of building approach, such as Green Star, which I'll get to a bit later. Our ESD team at AECOM uses eTool. I understand it's a pretty popular option. There are others out there. Quick Google search gave me a name of a couple of others. They tend to have internal databases and are probably more comprehensive than something like EPIC. We've got access to that at AECOM, so we are working with our ESD team and are looking at doing a comparison between EPIC and eTool. But for what we're doing at concept design stage, I think EPIC is sufficient. I think one thing that we shouldn't be doing is chopping and changing between databases. So if you're using EPIC for your concrete scheme, you don't use a different database for a different scheme at the same time of the project. And then once you get further down the line and you're heading towards construction, you start looking at environmental product declarations. Go to the next slide, Lachie. Like EPIC, EPDs cover A1 to A3 emissions. They're produced by specific suppliers. And so once you're further along in your project, you can you can start thinking about the exact material, where it's going to come from. EPDs are standardized, so they're international standards covering how to put one together. and you can get an EPD for just about anything like food, clothing. My understanding is they're most commonly used in the construction sector. And as your scheme is developed and locked in, you can start comparing suppliers, like different concrete suppliers for the emissions for their different mixes, and get into a bit more detail. For steel, there's not a whole lot of competition in Australia, but our steel also isn't particularly efficient, as we typically use blast furnace steel making. So that's more carbon intensive than electric arc furnace, which is used more extensively elsewhere in the world. So it could be that sourcing your steel internationally might not be as bad from a carbon perspective as you might think. And the additional transport emissions could be offset by more efficient steelmaking processes. But that's the sort of things you need to start thinking about when you get this sort of to this stage of the project. Large timber like CLT panels and glue lam, as Lockie touched on, you might end up specifying it and then think it's going to come from Australia, and then end up getting it from overseas and partially negate the benefits because of the transport. What we haven't included, and I'm not sure if it's really been talked about much, is the A5 emissions. It's quite, so that's the actual emissions on site. There's not a whole lot of good data on this. I'd say it's probably less important overall in terms of actually reducing your emissions. The difference between different schemes probably isn't that large, and it's probably the sort of things that reduce embodied carbon would also reduce your site emissions. Things like, if you've got less material, then you need less craneage. Something like if you use prefabricated elements, so you had less time on site, then you would have less emissions because you've got less overhead power and all sorts of things that it takes. But most of this stuff would be covered in terms of a comparison in the A1 to A4 cradle to site type emissions. And then, as you get further on, if you're going to do something like Green Star, which I'm about to get to, your site emissions will be calculated through that. And probably the biggest reduction in site emissions would be to not build at all, obviously, which is what Will was talking about earlier. So that's definitely, regardless of the scheme, if you can build less or not build at all, you're going to reduce your emissions across the board. So moving on, I'm going to talk about Green Star a little bit. Green Star's one of a number of sustainability rating systems for buildings globally. It's called, their tagline is Australia's largest voluntary and truly holistic sustainability rating system for buildings. It's basically a point system whereby you satisfy certain minimum provisions and you get enough points, then you get a rating. It's not just about embodied carbon or even environmental issues. It covers the whole building, how it affects the people around it, society, the environment. Practically, from a structural engineering perspective, our influence is generally on what we've been talking about, as in the material usage. And not just minimizing materials or picking the lowest carbon materials. It also makes you think about responsible material production across the whole supply chain, so whole kind of life cycle analysis of your materials. So, things like the waste management practices of the mine which supplied the nickel for your steel alloy might come into it, the water usage of your concrete batching plant. There are points available just for choosing products from a manufacturer which can provide you with a life cycle analysis. So, I think that the thinking is, by the time a supplier has gone to the effort of following the whole supply chain and published their findings, you can probably get the supply chain is at least somewhat responsible. So I should mention there are changes afoot. From late this year, the design and as built, which I've got mentioned there, that was the old rating system. It's no longer going to be acceptable for new building submissions. And there's the new Green Star buildings, which is coming in. The new system is a bit more nuanced. one question we haven't got to the bottom of is this idea of a reference building, and sort of who decides what the acceptable reference building is. You know, you can imagine someone throwing some extra concrete into their reference building to make the scheme look better. That's obviously not what we're trying to achieve. We're trying to reduce our emissions. So I'm assuming there'll be some peer reviewing that'll go on, and you'll need to justify what your base scheme is. But basically, you have a reference building, and then you have your final scheme, and you prove that the scheme is 20% less carbon intensive. It's not just for the structure, it's for the entire building. So I'm expecting ESD teams will be keen to see how far we can push the structure. As Will mentioned, the structure is a very large proportion of the building. So, you know, if we can reduce our structural emissions in a building by 30%, say, for argument's sake, compared to the reference building, then, you know, you might not need to do anything to your fit out at all. You know, it's basically, yeah, it gets a lot more complicated as you go into more depth for this. So finally, I'm just going to mention our local carbon reduction targets. So you might already know that our federal government has kind of been dancing around a net zero target for a little while. By the time they announce it, as Will said, it's inevitable, you know, it's going that way across the world. By the time they do announce it, it'll probably be somewhat symbolic from a practical perspective, as all of our states and territories already have net zero targets. What we do seem to have from the federal government is agreement on meeting our Paris commitments by actually reducing our emissions, rather than using the somewhat controversial Kyoto carryover credits that were being thrown around. That would have seen reductions being claimed without actually reducing emissions year on year, so wouldn't have really helped. Even without carryover credits, our target of 26 to 28% reduction on 2005 emissions by 2030 isn't really particularly ambitious. The government's main climate change advisory body in 2015 recommended a target of somewhere in the realm of 45 to 65% below 2005 levels. But again, a lot of some of the states and territories have picked up on this one with more ambitious 2030 targets than the federal government target. And just to finish off, I'll point out that Tasmania doesn't actually have a 2030 target, but that's probably because it's actually already achieved net zero. In 2018, it emitted negative 2.2 megatons of CO2 equivalent, which is down 111% from 2005 emissions. So, you know, I mean, obviously not every state is Tasmania, but, you know, it's a story that shows that we can achieve something. And yeah, that's me. Thanks for listening. And I think we're almost out of time, but we were going to throw it to questions. Is that right, Susanna?
Yes, we are going to throw to questions. So I think the first question is for Will, and it's from Farah. Is using 10% less material the only way to reduce emissions, or should we be combining with using more sustainable materials?
Yeah, okay, thanks. So yeah, that's a good one. So when we say the triangle that I showed that talks about using less stuff and then specifying a low carbon material, what we're not saying is, you know, just fill everything in concrete anyway, but use less of it. What we're referring to when we talk about the specification of the material is don't go assuming you're going to end up with a low carbon version of a certain material before you've done everything else you can do. So most low carbon equivalents of materials are based on the use of some kind of limited resource, some kind of finite resource. So with concrete or with cement, it's cement replacements, which are in finite supply, and around most parts of the world, we already use as much as we have. With steel, it's the percentage of scrap that's available. And again, we already use most of the scrap that's out there around the world. And even with timber, you know, it comes from different manufacturers. You may not have got your supply chain locked in. So when you're doing your carbon calculations early on, you should assume that you're going to use the normal version of whichever material it is. That's not to say, of course, that you shouldn't compare different materials. You know, what would be the difference if this was a timber scheme or a steel scheme or a concrete scheme? What would it be if I was doing, you know, a post-tension concrete scheme? I'm going to use less material, but might have a higher amount of cement in there to give me a higher strength. What would it be if I was building in, you know, some kind of other bonkers thing like earth or whatever? Yeah, absolutely think about materials as well as using less stuff, but you, as a sort of rule of thumb, you're going to need to work on the basis that it's the normal version of that material, and you're probably going to need to use 10% less for it than you would have done last year, either way.
Thanks, Will. The next question is probably for Ricky and Lachlan. So it's from Mike. He said that not every client will commission 2 parallel designs for their building as your example. First of all, was that just something that AECOM decided to do, or was that requested by the client? And I guess the second part to that question would be, what would be the approximate additional design fee to carry out a carbon assessment as proposed?
Thanks, Susanna and Michael. I think that's a really good point. Yeah, on that study that we did, the client was, I guess, driven by trying to find a sustainable solution, but also not sort of pay a huge cost penalty. And I think the indecisiveness kind of led them into a category of actually paying for 2 full designs. But I'm currently working on something that just only popped up a few weeks ago, where we're comparing a timber building and concrete building very similar to this in Melbourne. And it's at schematic design phase. We don't really have much more than sketches and a few column sizes and the like. And I think when chatting with Will previously about this, I think Will made a really good point when we talked to him a little while ago, is that it's probably less important what that final figure is. It's more important being able to compare the two and understand the difference between the two of them. So I think from spending, I think I've spent about 2 days of work and we are actually getting paid to do this work, but 2 days of work coming up with a schematic design with some sufficient sizing to be able to compare the timber and concrete scheme on this current project. And we're actually sort of road testing the IStructE tool to be able to measure that as well. And I think there's opportunity there for us as well, for the people who are more sort of scripting and parametrically minded, to be improving the way you do that, using the parametric tools to quickly design a building one way and another way and run many, many different options and actually compare them and find an efficient pathway through it.
Thanks, Lachlan. The next question is from Garth, and it's probably a question that all of you might have an opinion on. But the question is, where do you see the scope split for this work between the structural engineer and the ESD consultant, and how do they collaborate together to maximise the outcome?
Ricky or Lachie, do you want to get first? Ricky?
Yeah, I'll have a go. I think it really depends, you know, on the project, and you know, if you have an ESD consultant engaged, they should definitely be involved and probably leading the process sort of in going forward in the project. But at an early stage, you know, it's something that a structural engineer can sit down and talk to, I guess, once you know what you're doing with this stuff fairly independently. So I sort of see it as, you know, if a client's come and says, I want Green Star rating 5, then that's definitely something that the ESD consultant's going to be leading on and the structural engineer is going to be feeding into. But at an early stage, you know, we can really be leading the charge, because the structure is such a high component, and also the structure is definitely something that's a bit of low-hanging fruit to some degree in terms of reducing carbon compared to other disciplines.
Yeah, I mean, I'd second all of that. I mean, you got to think of this like, this is just good design, right? I mean, carbon is just a metric for efficiency. It happens to be a metric that you can actually compare different materials to each other. But for a very long time, you've walked past somebody's desk and they've got long span roof on their scheme, and you can't help but ask how many kilos of steel per square meter they've got, and then tell them that somebody else did it better, right? It's the same, but with something that works across all different materials. So I agree that in the early stages, particularly, you need to be able to do this as a structural engineer, because you need to be able to advise clients as to where they're going to find carbon savings, and you need to be in a position whereby in a few years' time, when there are carbon targets and carbon limits being brought in for different planning areas and stuff like that, and you've got an architect coming to you, or a client coming to you to say they're bringing to you a carbon budget and they want to know if they think this is feasible, you know, you want to be able to help them answer that. You really, you know, you don't want to be losing control of this stuff to, you know, the equivalent of accountants and QSs. Otherwise, you don't have control to be able to change what we do with it. So this also ties in quite well with the previous question about fees and costs and stuff like that. I mean, to do some really quick carbon sum, I mean, it's the simplest structural engineering sum you'll do in your career, right? It's quantity times by a number. You got to pick the right number, but it's pretty straightforward. So to be able to just do that as part of what you offer at concept stage without putting any additional fees in, I think will just get you to the point where you can then do it quickly. You can do it as part of your design process. You can give clients, you know, really high quality advice on, you know, meeting these targets that are coming out, and set the project up in the right direction. If you then hand over all the carbon accounting to somebody else, once you're into sort of detailed stages, fine, but at least you've set off in the right direction. I think that's the important thing here.
Great, thanks for that. The next question is probably for all of you again, and it's from Chris. The timber versus concrete is interesting. It says, timber, you were talking about cutting down forests and damaging biodiversity that could be regrown. Concrete, you're quarrying, so not only removing forests, but then keeping that area exposed for the life of the quarry. Is there a way to quantify biodiversity impact of a material, not just carbon, or does Green Star do that?
So I don't know about Green Star. I'm hoping one of you two can answer that bit. But I mean, as a general rule of thumb, don't think that the use of timber is going to involve chopping down these like amazing biodiverse old world forests. I mean, it's more like farming, to be honest. It's like growing wheat. I mean, there'll be acres and acres and acres of land. They'll chop down a certain amount of trees every year, replant them, move on. It's done on rotation. If you're using timber, it should always be sustainably sourced, so either FSC or PEFC certified, which means that it will be replanted, which means you can guarantee that sort of sequestration is going to keep happening. But you're taking this material from a part of the world that's now been dedicated to doing that. It's not going to be particularly biodiverse. I don't know what the different rating schemes in Australia say in terms of biodiversity and land use and stuff like that, but this is a topic that's becoming, you know, more and more a topic of debate in the conversations I'm having is, you know, how do you also include all of these other metrics at the same time? But again, you know, don't forget that the impact on carbon that you're having here is massive, and that's driving a lot of things. And there's other industries that I think need to be talking a lot more about, well, how do we plant more biodiverse forests, and how do we make sure that, you know, wetland restorations and things like that are happening in a biodiverse manner. So yeah, good not to confuse them, but it is obviously good to keep both in mind. I don't know, Ricky or Lachlan, do we know about the Green Star?
I'll just mention with Green Star, I mean, it is definitely included. You know, Green Star looks at the whole life cycle of a material, and just in general, in terms of classifying a building, it's not just embodied carbon. It really there's 7 different categories, which are responsible, healthy, resilient, positive, places, people, and nature. And, you know, the different credits that you can get touch on, you know, some like they come from one of those categories, but they often, it's in the documentation, they often also touch on other categories at the same time. So yeah, it will come into it in Green Star if you're pulling down virgin forests.
Yeah, the other thing I probably should have said as well is that this is why the sort of reuse agenda is so important, because, you know, even if you've got your design to be as efficient as it possibly could be, if you've got to go and quarry a bit more of a hillside out, or you've got to go chop down more trees, that's always going to be, you know, that's always going to have more negative effects than if you'd been able to just reuse what you already had. So a good example of this is recycled aggregates in concrete, which hardly do anything to the carbon footprint of the concrete, because most of the carbon footprint is due to the cement contents. But by using recycled aggregates, you're not going and dredging gravel out of, you know, some birds' homes, or I don't know exactly where you get it from, but there's going to be far less disruption to the sort of natural environment if you can reuse what you've got. So yeah, this stuff sort of does need a feature in our conversations, but it's maybe a bit harder to quantify at the moment.
Right, that's a very interesting point that you make, Will, about the recycled aggregates. Yeah, not actually being that much of the carbon content, but there's other impacts it has.
I need
I'm going to ask.
That's the only
Oh, sorry.
example. That's the only example I ever used for that one. I need to look up another one, I think.
Okay, I'm going to ask one more question. Well, and then as soon as I say that, lots of people put extra questions in there. But the next question is from Anton, and does the carbon assessment evaluation technology take into account for the ever-increasing renewable energy used by aluminium iron smelters? Example from battery storage. How can the construction industry ensure we are not compliant on this progress and not just to rely on these improvements to achieve 10% per year reduction?
Yeah, it does take it into account, right? Because I think an EPD only lasts for 3 years, which means that if you're a steel producer and the grid has moved on in the last 3 years and is now lower carbon, then when you get reassessed, you should get a lower carbon factor. And I'd say that a lot of material suppliers and manufacturers are trying to align themselves to Paris-aligned targets and are setting themselves up to reduce their emissions. We should obviously do some pushing as engineers, because we do sort of drive where our material comes from somewhat, but we shouldn't assume that we're the only people doing the pushing. You know, the steel industry are setting up responsible steel, which is kind of like FSC accreditation but for steel, and that's going to include greenhouse gas emission limits, which then is likely to reduce over time. I assume the cement industry around the world is going to start doing the same. So yeah, we're not the only ones pushing on this. Sorry, Lockie, I think I jumped in front of you then.
I know largely along the same lines, and just on that point of the embodied carbon, like the greening of the grid is a really interesting metric when you start looking at operational efficiency. But largely from an embodied carbon as a point of now when you're building the building, I suppose it's that one-off big cost that you pay at the start based off of the materials that are as they are now. So it's important to use, you know, the current data now for your building, or at least if you're going to do it in the next couple of years, but remembering that will change and being aware that we've got to keep track of it as it changes and hopefully improves.
Great, thanks for that. What we might do, so there's a couple more questions that did just come through, but I'll save the questions from this chat and send through to Ricky, Lachlan and Will. They can answer it, and then we can send out an email with the answers to those questions to all the participants. And there was also a question asked at the beginning about if we could share the presentation and links afterwards to help cascade the message, and we'll organise that as well and send it out to participants. I did also record this, so all being well, technology works and we'll have a recording. So if you're after a recording, let us know. Otherwise, thanks everyone for joining, and big thank you to Ricky, Lachlan and Will for taking their time to present. It's, you know, Will's gotten up extra early for it, being over in the UK, and it's a bit later down. I don't know how many people are coming from Queensland, but it's a bit later down in Melbourne for Ricky and Lachlan, so they're giving up their Tuesday evening to give the presentation. So thanks to everyone, and thanks to everyone who actually attended as well. It's really great to see people are interested in this topic. Thanks, everyone.
Thanks, Susanna. Thank you, everyone.
Yeah, thanks, Susanna, for organising. Thanks, everyone, for coming along.